Hello, so today's video is going to be about the topic completing the square. So again, this is a kind of a revision of the GCSE topic, because this is kind of a GCSE topic as well. So completing the square is to do with essentially rewriting quadratic expressions. So let's just consider this quadratic expression. We've got the quadratic expression, a number times x squared plus a number times x plus c. This is just the general format for a quadratic expression. So completing the square is a technique where we can write this expression in the form a number times by x plus another number all squared, plus this constant at the end where d, e, and f are constants. So it's just a technique where we can rewrite this expression into this expression there. So yeah, how can we do this? Let's go to the next slide to look at this. So let's take the expression that we had. So ax squared plus bx plus c. So what we can do is actually just factor out an a from the first two terms. So I'm going to factor out an a from the first two terms. So if I do that, I get a times by x squared and then plus b over ax and then plus c on the outside there. So just by factoring out an a, we get this result there. So factoring out a from first two terms. So that's the first step there. The next step I'm going to do is I'm just going to now look at this a squared x squared plus b over ax, and I'm now going to do the technique that we've done from GCSE, where we write it like this. We're going to put this into brackets there. We're going to half this constant in front of the x there, the half this coefficient. So half this, we get b over 2a. And then we're going to square that. And then we're going to subtract the square of this number here. So the square of b over 2a, subtracting that, and then plus this extra c at the end there. So if you remember from GCSE, where we had examples like x squared plus 4x plus 6, and we had to complete the square. So the trick was that we put the brackets there, we put an x into there, and then we half this coefficient there. So when you half plus 4, you get plus 2. And then if you square that and then subtract this number squared, and then remember to add the 6 up there, we got exactly the same thing that we started with essentially. So this here is the same as this thing up there. So I'm just applying this technique here, but obviously we're not using like numbers, we're using letters instead in this case. So it's just by applying that same technique here. And then what I'm going to do is just expand the brackets. So if we expand the brackets, we get a times by x plus b over 2a all squared, and then subtract by a times by the b over 2a all squared, and then obviously this plus c at the end there. Okay, so we get that. I'm just going to move this to the side. Let me try and do it again. Okay, so we get that. So now I'm just going to simplify what we've got. So we've got a times by x plus b over 2a all squared. Then subtract. Okay, so we've got a times by b squared over 4a squared. B times b is b squared. 2a times 2a is 4a squared. That's where I've got that and that from. And then we notice that the a cancels out there and there. So we can cancel 1a on the top and 1a on the bottom. And then we got this plus c there. Okay, let's just tidy this up a little bit further. So we get a times by x plus b over 2a all squared, and then subtract this b squared over 4a, and then we got this plus c here. We obviously, well, I mean, it's better if we try and get a common denominator for this plus c, so that we've got so we match the denominator with this 4a there and this 4a there. So what I'm going to do is I'm going to put a 4a here, and so that means that c, to get this c to be the same as this fraction there, I need to write 4ac up there. So again, if you do 4ac divided by 4a, you get c. So this fraction here is just the same as this plus c there. And the whole point of doing that as you'll just see in a second when I make this writing smaller. The whole point of doing that is just so that we can just tidy up our work a little bit. So we get a times by x plus b over 2a all squared, and then subtract, well, actually, I'm going to write it in a different way. I'm going to say plus. So plus 4ac subtract b squared over 4a. So now we've got this common denominator of 4a. That means we can actually add the top numerators of that fraction and that fraction. So 4ac take away b squared is 4ac take away b squared. So we get this here. And so we've now completed the square. Yeah, so essentially, when we complete the square with this quadratic expression here, we get this result here. So I'll just write this on the next page. So ax squared plus bx plus c is exactly identical to a times by x plus b over 2a, x plus b over 2a all squared, and then plus this 4ac plus 4ac minus b squared over 4a. And that's as a result of completing the square. So you don't need to learn this formula, but the technique holds true for any quadratic that you have. So the technique is just the same. So you want to factor out this constant value a. I mean, if the constant value a is just the number 1, you don't really need to worry about this. But in general, if a is like the number 2 or the number -2, you want to factor out this a at this step here. So that's what we did here. And then you want to use this completing the square technique on this quadratic expression inside there. And that's just by using the logic that we know from GCSE material. So GCSE material here, where we just halve the coefficient of the x coefficient, and then we put that into brackets like this here. So for example, this x plus 2 all squared. So we're just using that logic here. Obviously, half of b over a is just the same as b over 2a, because b over 2a plus b over 2a is just b over a. So yeah, we square that, we subtract this number squared, and then yeah, we obviously add the c at the end. So it's just a case of simplifying all that, and we do get this result here. So that's just an example to illustrate how we complete the square, and what the technique is all about.